focus point during our discussions. Okay, so to begin our conversation, I would like to just introduce a particular a link which I'm going to. I'm hearing some voice. Can you please go on mute, please? All right, thank you.
Lab coordinator, kindly mute everybody.
Yeah, I think you're only seeing my particular PPT, right? You're not seeing any web browser or anything else, right? So I think I'll have to probably reshare it. It's okay. So I'm just putting in a particular link on the chat. Okay, so I would request all of you to kindly look into click on that, and I will share my screen here. Okay. I would like you to answer this particular question. So you should be able to find some places where you can provide your comments. So I think we are we are close to 100 people here. So I would like to see some answers coming. So why do you think security is important? So I would like to kind of start a flow for our discussion, and then want to understand your thoughts, and maybe we can touch on any specific topics during our discussion. So I hope everyone is able to access that particular link which I shared. If you can, you have to submit the answers, and those answers will come up here. So your names will not come, but your answers will come here. Okay. I'm not seeing any answers so far. Can you try and submit it?
It's opening. It's working. Link is
perfect. Okay. Why is data security important? Okay, data, probably protecting data and information. Yes, great. Let's keep them coming. Okay. Preserve. I think you can actually submit multiple answers, so don't feel shy. You can resubmit the answers. Okay. For privacy, I see Sabiha is answering on the chat. I would appreciate if you can answer on. Yeah, please. Okay, so to keep the information to prevent data breach, perfect. So keep data, I think, unseen by others. Okay, good answers. Yasha Dubey is typing for authenticating and securing data, or we can say securing integrity. Okay, fine, fair enough. So please use the Mentimeter or the Menti tool which is there. So it gives us information of what everyone on the in the conference or our webinar is thinking, right? Unseen. Okay. Nice to see more answers coming in. So I'll wait for 1 more minute. I see only 12 people have answered. So I would appreciate if most of you can provide your answers. What do you think? You can be just a single word answer, or if you want to write a sentence, that is fair enough. Prevent illegal access. Perfect. Great. So information, authentication, and author. Okay. So I understand it's authorization probably. Okay. Encrypt. Yes. Seema, if you can answer on the Mentimeter, that would be great. Safeguard our data, keep information safe. Yes. All correct answers. For confidential data. Okay, ourselves against fraud. So protect ourselves against frauds. Yes, very good. That is definitely CIA. Yes, definitely we are going to talk about the CIA. To keep information secure. Identity theft, Anmol, very good. Thanks for that. So privacy, yes, a very important topic. So security and privacy are kind of interlocked. So definitely to hide I believe personal information is what you meant. Exactly. Okay. 30 more seconds and we'll pause here and move to the next question. All right. Anonymity. Yes. Okay. Very apt for our discussion today. for confidential data, prevent illegal access, other houses. Okay, ensuring confidentiality. Great. So I think it's a great picture to take as well. So, so I'm taking a kind of small screenshot here. Let me just take you to the next question which I have. Okay, it is about cryptography. Okay, so I think some of you have already started answering these questions. So the topic that we have is specifically cryptography and how cryptography becomes the mathematical backbone for all that we are discussing. So you can discuss, we are discussing what blockchain, how it is going to provide more secure service, secure platform for developing next generation applications, platforms, and other things. So what is your perception? What is cryptography basically? So if you can tell me, I think I will definitely use this as a feedback for my today's session as well as the session which is coming up tomorrow morning. Okay, security using codes. Okay, codes, catchy word. Converting one form of text to another form. Yes. So it depends. We'll discuss on that. There are differences between encoding, encryption and hashing. So we'll touch upon that particular topic. Cryptography, securing data. Probably yes, that's correct. Protecting information, authenticity. Okay. Guys, I'm having only 4 answers here. So if you can answer, let me see. I think let me just reload the page and see if many of you have already answered.
It is actually not showing the question. Can you refresh?
Yeah, sure. I'm doing that. Okay. Okay, slide not active. Now it should be active. I'll present it and you should be able to answer the questions. If you can refresh
can you please
your
also
page,
put the code in the chat? The code, because we're not able to see the code.
Yeah, I think it's sure. Okay, I think it's okay. So if you can type it in chat itself, that's okay. I think we are facing some technical difficulties on the Mentimeter. It's fine. We are starting to get answers. I think the same code should work. Whoever asked the question, same code should work. But if you are not able to answer there, yeah, it's okay to put it in chat. It's just to start a conversation here to understand what is your perception of cryptography, and that will help me to take it further. Okay, great. So keep your answers coming. So we'll stop in about a minute or so. Okay, it's hidden writing. Yeah, an interesting concept. It takes us to a concept called as steganography, which we are going to cover probably tomorrow, if time does not permit today. Secure communication, very well. Absolutely, it's a crux of cryptography. Integrity, yes, integrity is also a significant part of why we use cryptographic functions and other things. Use mathematical formulas to hide the message. Yes, mathematics, definitely mathematics has a big role in cryptography. Right, hiding data, method of securing and hiding data, correct. Secure data by secret writing, yes. All right, so more answers coming in here. Encrypt, symmetric. Okay, symmetric, asymmetric cryptography. Yes, we are going to talk about that today. Data integrity, authenticity, encode, protection information. Great. All great answers. Thank you so much for sharing this. And let's get back to our session. So thank you. I see people are keep answering still. It's a key exchange. Yes, we are going to talk about that. Great. Confidentiality. I think that is one thing which is standing out. Thank you for answers. So I'm going to stop this for now, and let's get back to our session. All right, so I'm going to probably stop sharing and share the presentation once again. Okay. All right. Can you please confirm if you are able to see my screen? I'm on the front.
Yes, sir. Yes, sir.
Thank you. Thank you so much. All right. So, all right. So we discussed about why is security, and more so, we look at security and privacy nowadays, because a lot of privacy compliance requirements have started coming in. GDPR is one compliance requirement in the European region. There's something called as California Act, which is in the California region in USA, and many of the organizations are based out of that. So if you are working or dealing with data coming out of people situated in these countries or these particular regions, these specific privacy regulations are applicable. So that is one of the things that drive security requirements in an organization, right? So we have to stay compliant. Otherwise, there are going to be hefty, a lot of fines issued for non-compliance. And definitely you have to protect your digital resources, and there are a lot of hackers who are trying to attack your systems to get unauthorized access to your data, business data, your customer data, or even at a personal front, your identity information, right? So to secure against digital identity, and we are going to talk about various other factors as well, but definitely protecting, if you are thinking like with respect to an organization, protecting your own digital resources, your customer trust that you have built over the years, for that reason cybersecurity and privacy becomes very, very much important for your regular business to function without any issue. Otherwise, you might have a very beautiful website, very beautiful business, but if you have some data breaches, it could cause damage with respect to your. Can you please go on mute, please? It's disturbing me. Thank you. So, if you are able to, if some hacker is able to get unauthorized access, you are going to lose your credibility that you have built. You are going to face a lot of law, imposed fines and court orders, and many. We'll see some examples in the next slide also, right, where people are finding it difficult once they have got data breach. Okay. So there is a website called as Information is Beautiful. It provides a lot of great insights, with data-based insights with respect to several topics. And one of the topics it covers is data breaches and hacks in recent past. So it has data from about, I think, a decade or so ago. And if you look at it, you will see various organizations which have undergone different levels of data breaches. Okay, so I want to share the particular website also. I'm having to kind of reshare it because it's allowing me to share only one screen at a time. So give me a second. Okay, so this is the website which I was talking about. So if you look at some of these bubbles, right? So I'll share this link in my references after this session. So don't have to worry about that. If you look at some of these bubbles, right? So if you click on this, Microsoft had a data breach, and that was because there was a server which was not protected, and it was basically, we call it as shadow IT, or servers which are not well maintained. The data breach could be because attackers are finding those servers and attacking them. And some of the other issues would be, even if it is a well-maintained server, if there are certain key security features not enabled, such as data encryption at rest. So which adds several layers of security, right? Even if an attacker has access to the data, in case the data is encrypted, they would not be able to make any sense of it. So we'll see how it works during today's call. But if you are not able to enable it, so that also could be a cause of a lot of data breaches, right? So that's why it is very important to follow security design principles. That is out of scope of this particular topic, but definitely something to keep in mind with respect to security. And a reminder that the cryptography, encryption, hashing, and so everything related to the cryptography is the backbone of how we are safeguarding our systems, and specifically the ones which are exposed to internet. Because with the exposure to internet, you are able to do business with all your customers and reach out to all the users. But on the other hand, you are also you are just at mercy of the hackers who are trying to attack you to steal the data, and we have to be extra careful about that. Okay, so coming back to our topic at hand, which is secure. Coming back to my PPT presentation. Yes. This particular, I would recommend everyone to have a look. It will be excellent case studies for you to understand why a particular data breach happened, and how what was the learning from it. How you can think about proactively defending your systems, your organization, or if you want to do some research, it could open a lot of avenues for you. All right. So going to the next slide. So I'm going to talk about the CIA Triad on this particular slide. Hope you are able to see this slide coming up. So CIA stands for confidence. Somebody mentioned on the Mentimeter also. Kudos to them. So CIA is the fundamental tenets of information security. All right. So whatever we do with respect to security or privacy, finally it comes down to one of these three elements. So either you do whatever to secure your systems, to prevent intentional or unintentional or unauthorized disclosure of data is termed as confidentiality. So whatever you do, so definitely cryptography plays a vital role in these things. But essentially, what all tasks that you do, what all measures that you take in order to protect against data theft can be put into the bracket of confidentiality. All right. So next is integrity. Integrity is something which guarantees that the message which has been sent by a sender is same as what has been received by the receiver. Okay, so in a communication channel, it is it's very challenging to maintain data integrity unless you have a secured pathway, and we'll see how that secured pathway will work during our session today. All right. So because you are going to send over an untrusted networks, because when we all have the basic understanding of the computer networks, that when you send some data from your laptop or your system to another friend of yours who is on the other side of the globe, or even just probably in the next building, so data travels across various networks, and it is possibly in untrusted networks, and before it reaches your sender, and vice versa, right? So it has to be ensured that your data is not tampered with while it is in transit, right? That's why integrity becomes very important. And whatever you do in order to ensure the correctness of messages which are exchanged between any two parties or any number of parties is called as integrity. All right. And definitely we'll see how cryptography plays a vital role here. And the third part of the CIA Triad is availability, where you provide assurance that the system would be stable. And any you might have heard about denial of service attack. So any action that we take, any procedures that we implement that is going to protect the system against denial of service, is everything is falling under bracket of availability. All right. So that is one, and along with that, you need to be aware of the AAA security framework as well, which goes to the next level and ensures that any system which is a non-public system, right? It ensures that the users are authenticated before. So it says that okay, users have to be authenticated to make sure that their identity is verified before they get access to a particular system. All right. So that is one. And even if there is authentication, there is a next level of scrutiny, which is authorization. Means all users might not have the same level of privileges. So there are different types of users. There might be administrators, there may be other privileged users, or they could be just end users, right? So they have to be authorized. So only an administrator would be able to perform administrative tasks. Any just end user should not be able to do an administrative task. So there is a segregation of duty. There is principle of least privilege. Again, I'm not going to delve into those topics in today's discussion. Right. Finally, accounting. So who has done what activity at what time? So all these kind of things are part of the. I would request for everyone to go on mute, please. I would request everyone to go on mute, please. Okay, so let's continue. So I think can you please go on mute? It's disturbing me. Thank you. I think we have already started discussion on the blockchain. What are the basics of blockchain? You have already underwent a couple of sessions, and you are going to spend a lot more in understanding blockchain, the intricacies of it. So I'm not going to spend too much details, too much time in this particular slide. But blockchain technology is something which is emerging as the next generation platform for developing decentralized applications and even platforms, and it has its inherent features which includes security, and we are probably going to talk about that security aspects in a bit of detail today and tomorrow's session, with respect to how cryptography is playing a hand in ensuring that particular security part of it. Okay, so again, blockchain. So we have seen a lot of the traditional applications, and at this point of time I would like you to kind of reminiscence the pathway that we have taken to reach here. So probably like 30 or 40 years back, even people were apprehensive whether internet is going to stay, or how internet is going to shape our lives. But visionaries took it forward, and there were a lot of innovations along the way. We started using internet for banking transactions, communications, shopping, and so many other things. And then it slowly it went through. We have experienced that in our lifetime, that it has revolutionized so many fields. Healthcare, social network, defense, and so many other things. I would be in loss of words to explain that. So now I believe we are at a paradigm shift. We have come to this stage, and from now on, I think blockchain is definitely going to have a major impact in how we are going to build next generation applications and platforms. And this is how we were thinking of internet back like about 40 years back. So now we are understanding about blockchain. So that gives me a lot of hope about how things are going to be built in the future, right? So what is blockchain? Again, I'm not going to spend too much time here, but I wanted to pick up a couple of words based on which we are going to spend next 1.5 hours today and 2 hours tomorrow. So basically, blockchain is you might have again be familiar with these terminologies or these definitions from previous sessions, but these are, finally, blockchain is a growing list of records which are called blocks again, and they are linked. So we are going to see how they are linked, how cryptography is helping to link one block to another, and it is secured using cryptography. So we are going to look at those aspects. And definitely there is one point at the final in the final bullet point which is mentioned there, that each block has its own signature. So what is this particular signature? So it's kind of an identifier for that particular block. So it is identified by the digital signature. So we'll see how the digital signature works, how cryptography has provides that mathematical foundation for to ensure that blockchain technology works, right? So that is what is going to be our string of thoughts for today as well as tomorrow. So there are a lot of mathematics behind. So this, in one slide, I wanted to share, provide multiple ideas for you. So there is cryptography. We speak about symmetric key cryptography, asymmetric key cryptography. We talk about hashing. We talk about public keys, private keys, or secret keys, ciphertext, signature, all these things which is coming up in next 3 to 4 hours. So I would like you to stay tuned for it. All right, so let's go one by one. So we have to understand this basic fundamentals, so that our rest of the 5 days becomes very smooth, and your at least the basics are firm, and you are able to understand the topics which are on which blockchain technology and other other hands-on which you are going to do are based upon. Right, so first thing is first. So whenever there are whenever there is a communication, right, between a particular uh, user, so let's say it's you, and then you have an application, a cloud-based application or a web application, where you want to do some transaction, right? It could be a banking transaction, it could be just a simple fetching of a particular information, it could be a social media, it could be an e-commerce or anything like that. So a man in the middle attack, which is one of the classic attacks that we all should be aware of when we talk about security, is when this particular connection, the original connection, is kind of replaced by another, a hacker or a malicious person who is called the man in the middle. Okay, so what this person does, or this particular connection does, is it will replace the original connection with its own. So user, instead of sending the traffic to a web application, it will send the request to the man in the middle, and man in the middle is able to do various things. We'll talk about those things, and send it to the web application and receive the information back and modify it and send it back to users. A lot of things that can be done. So there is an approach called as Triad, which tries to depict what all different attacks can be done using the man in the middle. So what we usually do is, when we are building something like a threat model, again, I don't want to deviate from the specific topic here, but uh, when we are trying to secure a system, we look at how we can protect our system from a man in the middle attack. Okay, so that for that reason, this becomes a very important topic, and that is done when we are building a threat model for the application or a system, where we anticipate what are the different kinds of attacks which are coming. So which are spoofing. One is STRIDE stands for the acronym for all these various attacks. Spoofing is when the man in the middle is kind of just advertising to the web application that he is that particular user. Okay, so the man is going to replicate a communication, but it is going to originate from the hacker and not the user, right? Tampering is when user is sending the data and he's going to forward, but before forwarding, he would actually modify the particular transaction. So, for example, if it says send some amount from my account to XYZ account, probably 100 rupees or 1,000 rupees, whatever, the man in the middle can just modify it, saying that send amount from my side, that is user side, to the hacker's account, and amount he can just modify it as well as he wish, as the person wishes, right? So that is one. So this is all possible when the particular connection is unencrypted, or it is a plain text exchange of message, right? So so if a man in the middle is able to understand what is the request being sent, he would be able to again further capture that particular data packet, modify it, and send it to the next level, and again wait for the answer and then send some other message to the user, right? So all this happens because the data is traveling without any security, any encryption, so as to say, right? Repudiation is one where man in the middle is able to send, but the user will never know that a different person has sent it. Information disclosure is when man in the middle will be able to find out some information about user and use it in a different attack, maybe not this alone attack, some other attack. So he'll understand about some from where is the request coming from, what is the device being used, what is the operating system of the server. So it happens in both the sides, right? And then denial of service is when the user gets the request, but he just drops the packet. He doesn't want to kind of provide access to the web application to user, or the other way around. So the web application is not going to send back the even if web application is sending back to man in the middle, they drop the packets. Okay. Elevation is privilege when you have additional set of vulnerabilities in the system, where a regular user is sending the request, and man in the middle is able to update certain parameters and gain access at a higher level than it is intended. So there are a lot of attacks. There are again several other attacks scenarios like abuse use case and things like that. Again, so this is the basic fundamental information that we need to be aware that lot of attacks are possible if the data exchange which is happening from the user or the web application is not protected, right? So that brings us to the question, how do we protect the data which is being transported? Like I said before, it's a complex network when it comes to internet, when we are sending messages from one system to another system. So this man in the middle attacker can be anywhere. He could be sitting next to you in your lab, or it could be somewhere in a country where the legislation is very shady, right? So it can happen anywhere, and we have to be very careful and ensure that the data exchanges between any two entities are secured. And encryption is the way to do it, and cryptography provides the mathematical background of ensuring that is successful. All right, so let's talk about encryption. I think this is the first particular slide where we're actually speaking about encryption. So what is encryption anyway? Right. So you have original text or message or data, whatever you want to send to the other person. So this is the sender, and you are using a particular mathematical function or a particular key which is used to scramble the original text. So this is an encrypted text, or we sometimes call it a cipher also. It is nothing but the product of the original text and the key which is used to encrypt the text, mathematical function. So finally, at end of the day, any data for that matter is just a stream of bits, zeros and ones, right? So you apply some mathematical formula and you get the encrypted text. And even if a hacker is able to access this particular data, like we saw here, they would not be able to do anything because they would not be able to understand what this encrypted text is. And that is where we take the high road. Like, fine, it's called as eavesdropping basically. So if you want to listen to what the two people are communicating, it's called as eavesdropping. So even if they eavesdrop, all they would see is gibberish. So some data which they are going to be making any use of, it's of no use for them unless they know the key to decrypt that particular information. And with mathematical function and some security measures, you can keep it safe. All right, we'll talk about that in coming slides. Okay, so finally you share the data and to the other receiver, and that receiver somehow we are able to make sure that he or she also has the key which is used to decrypt. Right, we'll discuss about the how do we share these keys and other things in the coming slides. But assume that they know how to decrypt this particular information, so only they will be able to understand the encrypted text, because they'll be able to descramble it, or get it back to original text. So this is the crux of how encryption works. So this is fairly simple, right? Okay, so here we talk about, from this concept we take to the next levels, understand what are the different types of encryption, and how does it work, how does the key exchange work, how do we ensure that the encrypted text is not you cannot kind of break the key, and various concerns and other things. So we are going to talk about that. All right. So next step with respect to our understanding is the two key different types of encryption. Okay, so you saw that in this particular screen you have one key for encryption and another key for decryption, right? And that itself is going to create the two different types of encryption. One is in case you have the same keys which is used for encryption as well as decryption, it becomes symmetric key cryptography. Okay, and because it is symmetric, it means that the keys are same, and because it is same, you have to ensure that only the receiver and the sender, only these two people know about this. So it's a private key. It should not be shared with anyone, because if anyone comes to know about it, they can as well implement that mathematical function to decrypt the message. So you have to ensure that these particular keys are very, very secret. Okay, so we are going to talk about these things also in separately, and know more about this particular thing. And asymmetric key is when these two keys are mathematically related. All right, so it's not that we are going to see what are those relations, and probably if not in today's session, we are going to talk about in tomorrow's session. We'll see how the time goes on how these keys are related. How do we generate public key and private key pairs? What are the different algorithms which are used, and various things, right? So know this. So you have one key which is used to encrypt, and another key which is used to decrypt. Okay, uh, there are different use cases for this and applications for this. We are going to talk about it in the coming slides, but this is the essential message, that you have two mathematically related keys. One is shared with everyone and another one is kept as secret. And this particular key, because it's a private key and one is public key, right? A sender, if some if sender is able to share this with key with anyone, it's fine, because all the at end of the day, the requirement is to send an encrypted message to the receiver, and nobody else should be able to see it during this particular transit. So it is okay, because everything will be encrypted, and only way to decrypt is using the decryption key which is there in the receiver side.
So, excuse me, sir. Actually, The encryption happens using the receiver's public key and receiver's private key, is not?
Sir, I think just to be fair to others, let's keep the question at the end. I will be definitely able to answer your question. Okay, you can put it in the chat, and I will be answering the question during the session itself. So if questions are not answered, we can take it up at the end. Thank you for your patience. All right. So at this point of time, I would like to kind of just touch upon a specific topic because people tend to kind of get confused about these two things, about encoding versus encryption. So are these both same? Are these both related? What are the differences? Things like that. Okay. So encoding is different from encryption. What does encoding do? Encoding provides a method to represent characters or any data, right? And the algorithm for encoding, retrieving the original text is public in nature. So anyone who has the encoded message can use the algorithm to retrieve back the original message. Okay, there are several applications for it. So you might have heard about Huffman encoding, or Morse code is one of the most popular encoding methods, right? Where we use to shorten the message length. So Huffman is converting your characters which has like 8 bits in size and long stream of characters. So it will be virtually 2, 3, 4 bits per character. So it is going to reduce the size of the overall message to a significant amount. Okay, so there are other things also like ASCII, UTF, even base64. So there are several industry standards. We are going to do a kind of a do-it-yourself hands-on session in just a while once I complete some of the theory part. Okay, so that is used in not just for shortening messaging length, but there are also some security attacks which can be prevented by using encoding, right? For example, when you are with respect to web security attacks like cross-site scripting, you use the hackers use things like script to exchange some data, as well as asking people to click certain links, and that is going to take in the details from their cookie storage or all their session details, and then send it to another server. So these are cross-site scripting, cross-site request forgery attacks. Again, not going into detail on that, but what happens if we use encoding is that the particular special symbols which are there in the script tag, right? Script tag. So they will be replaced by the encoded characters, and it will ensure that the browser is able to just interpret that and show it as a script. But when it is actually getting stored in the database, it will be stored as a encoded message. So it will avoid cross-site scripting, cross-site request forgery, and many other web security issues, right? So that is one of the applications, one of the important applications of encoding, right? Comparatively, encryption is different. So, and the reason for using encryption is fundamentally different. So it is to make sure that you protect the message or encrypt the message, rendering it unreadable, right? So without the key which is used to which is used to decrypt the message, you will not be able to retrieve the original text. Okay, so there are a lot of applications for encryption which we are going to see in today, and of course blockchain technology itself is one of the primary use cases that we are going to learn over this week to ensure confidentiality. So when I talk about relating it back to our CIA triad, so it ensures confidentiality of data during transit as well as at rest. Okay, and it will also ensure, we'll see how it happens. It will also ensure the integrity of data in transit, because no one is allowed to tamper it. So it provides a kind of a tunnel or a secure bubble for sharing the data, a secure tunnel for sharing data from the source and destination. So there are examples like I think we discussed in the previous session, previous slide. There is symmetric key cryptography. There are AES, DES. We are going to talk about it in brief in the next slide. There are also about asymmetric key cryptography schemes. Okay, so let's learn about this encryption. So we are not going to talk about encoding too much. We are going to be concentrating on the encryption part of it. Okay, but we are going to do some hands-on activities on both of them today. Okay, so is encryption a very recent thing? No, answer is no. So we have been using encryption schemes since a long time. Since I wanted to share an example from history, and one of the good examples, I think, very well quoted example with respect to encryption is the Caesar cipher encryption, right? So Julius Caesar used to use this particular encryption methodology where the characters used to be kind of if you can see here, the plain text is if they want to send some message to another person, that attack at dawn, right? But if they send it and somebody else sees the message, they would get the information, and that particular attack would have been foiled. So they had to send the information from one place to another without others getting to know. So one of the things that they used to do is use this Caesar cipher, where they would use these characters, and they used to kind of map A to another character, which is kind of a rolling shifts. So here, this particular one shows 3 shifts. A is mapped as D, B is mapped as E, and so on, right? And then it's like a modular function, right? So once you have reached Z, it comes back to A. So what happens? The plain text is kind of shared as this message, which is not readable unless you have this particular key, right? So same key, it's like a same key which is used for decrypting the particular message. All right, so that the general at the other side would have that information, and they used to descramble it. So if they have received D, they have to substitute it by A. So this is one of the early examples with respect to encryption. All right. So one more examples with respect to encoding I would like to share is from our own history. Is that we used to do a lot of mathematical things, and we used to use this interdisciplinary kind of experiments where we used to encode a lot of messages through poems, right? And the poems would be in a particular order, and there is a scheme which is called as Katapayadi, which is also a modular scheme for encoding messages. So you can see Katapaya. So that's how the name comes. So there are modular functions assigned for the vowels, or not the vowels, not all the consonants of the Sanskrit characters. All right, so that is used, and there is a Sanskrit hymn also, which actually speaking, if you apply the Katapayadi Sutra, it will provide the value of pi till I think around 15 or 15 plus decimal points. So they used to encode the value of significant numbers through just plain poems using a particular mathematical notation. So encoding or encryption is not a new concept to us. We have been doing it since a long time. All right, so that's something I wanted to share with all of you. Okay, so let's cover a couple of other slides, and then we'll go to a hands-on session, and then come back to our learning today. All right, so symmetric systems, or the symmetric cryptography systems, the pros of it is that it is computationally very faster when you compare it to the asymmetric key algorithms. So there are, in asymmetric key algorithms, there are a lot more mathematics involved to do the decryption, do also the key exchange mechanism and everything. So there are a lot of overhead which is involved. So in that perspective, ideally speaking, if I have to choose with respect to mathematical computation, which is better or which is ideal, I would choose the symmetric key cryptography because it is much faster and it is difficult to break in case you use a decent enough key size. So we are going to talk about the key length and how that adds to the security of the cryptographic function. We are going to talk about it, but just for reference, you say that okay, if it's a decent size of 128 bit, or nowadays we use 256 bit for AES, but even 128 bit is going to provide you a decent level of security. So it will be very hard to crack the key. And again, it provides confidentiality that goes without saying with any cryptographic function, right? And what is the weakness? So even though it's very faster, it is because it is a private key cryptography, it is very difficult to implement because you need to have a secure mechanism for key exchange. So there is always an overhead of sharing the secret key with the sender or the receiver when you want to communicate. All right. So because just think about the various scenarios. So now if I have to send a message to you, I would just come and whisper into your ears. But how will you be able to do when you are catering to millions of users in the digital world, and you want to ensure that the messages are sent in a confidential